Let's do the math. The observable universe contains roughly 2 trillion galaxies. Our own galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Astronomers estimate that approximately 1 in 5 Sun-like stars hosts a planet in the habitable zone, the range of distances where liquid water could exist on the surface. Conservative estimates put the number of potentially habitable worlds in the Milky Way alone in the tens of billions. Tens of billions of potentially habitable worlds in one galaxy. Now apply some numbers. Say only 1 in a million of those worlds develops life. That still gives you tens of thousands of living worlds in our galaxy alone. Say only 1 in 1,000 of those develops intelligent life. That's still dozens. Say only 1 in 10 of those develops technology capable of interstellar communication. You still end up with multiple technologically capable civilizations in the Milky Way. Some of them potentially billions of years older and more advanced than us. Under any reasonable set of assumptions, the universe should be teeming with intelligent life. Some of it should be detectable. Some of it should be trying to reach us. Some of it should have already colonized enough of the galaxy that evidence of its existence should be unavoidable. And yet, the sky is silent. No signals, no structures, no evidence of any kind that any other intelligence has ever existed anywhere in a universe 13.8 billion years old. The silence is not just strange. Under the math, it is almost impossible. This is the Fermi paradox, and every possible explanation for it is disturbing in its own way. This is Deep Space Declassified. New classified file every week. Subscribe before we go further. Let's get into it. The question has a specific origin. A lunch table. Los Alamos, New Mexico. The summer of 1950. Enrico Fermi was one of the most brilliant physicists of the 20th century. He had built the first nuclear reactor. He had worked on the Manhattan Project. He understood better than almost anyone alive what technology was capable of doing in a short period of time. At lunch one day with colleagues, conversation turned to a newspaper cartoon about aliens. And Fermi, in the middle of an otherwise ordinary meal, looked up from his food and asked, "Where is everybody?" He was not asking rhetorically. He was doing what physicists do, applying numbers to a problem. The galaxy is old. Civilization is young. In the time it took for intelligent life to evolve on Earth, older civilizations elsewhere in the galaxy could have expanded to colonize every habitable star system thousands of times over. The galaxy should be full. Why is it empty? His colleagues remembered the question. They did not have an answer. In 1961, astronomer Frank Drake formalized the problem into an equation. The Drake equation is a series of factors multiplied together to estimate the number of civilizations in the galaxy currently capable of communication. The rate of star formation, the fraction of stars with planets, the fraction of planets with conditions suitable for life, the fraction where life develops, the fraction where intelligence emerges, the fraction that developed detectable technology, and how long those civilizations survive. Most of these variables are now known with reasonable precision. The ones that remain unknown are the ones that matter most. How often does intelligence emerge? How long do civilizations last? Those two unknowns span an enormous range of possible answers. And where you land on those unknowns determines whether the universe should be full of civilizations or effectively empty. Before we get to the proposed solutions, you need to understand what a detectable advanced civilization would actually look like from a distance. Physicist Nikolai Kardashev proposed in 1964 a scale for classifying civilizations by their energy use. A Type 1 civilization controls all the energy available on its home planet. A Type 2 civilization controls all the energy output of its star. A Type 3 civilization controls the energy output of its entire galaxy. We are currently somewhere around Type 0.7. We use a fraction of the energy available on Earth and have barely begun to leave it. A Type 2 civilization, one that has harnessed the full output of its star, would be detectable from enormous distances. Freeman Dyson proposed that such a civilization might build a structure around its star to capture all its energy, a Dyson sphere. A star completely surrounded by a collecting structure would appear dim in visible light, but would release the energy it collected as waste heat in the infrared spectrum. It would glow brightly in infrared and be invisible in optical wavelengths. Astronomers have searched for infrared bright, optically dim stars that might be Dyson spheres. They have found candidates worth investigating. None confirmed. A Type 3 civilization would be reshaping entire galaxies. It would be visible across the observable universe. We have examined billions of galaxies. We have not found one showing signs of being actively managed by an intelligence. No Dyson spheres confirmed. No artificially structured galaxies. No megastructures of any kind that have withstood scrutiny. In a universe 13.8 billion years old, in which a civilization only a few million years older than us could have colonized the entire galaxy, the complete absence of any such structures is not a minor data point. It is the core of the paradox. The solutions proposed to the Fermi paradox are not comforting. They fall into roughly two categories. Either intelligent life is genuinely rare, or something happens to it. The first major proposed explanation is the Great Filter. Economist Robin Hanson introduced this concept in 1998. He asked, if there should be many advanced civilizations and we see none, then somewhere between simple chemistry and galaxy colonizing intelligence, there must be a filter, a step that almost nothing passes through, something that stops the progression from simple matter to spacefaring civilization, so effectively that the expected explosion of life and technology across the galaxy never happens. The critical question about the Great Filter is not whether it exists. It probably does. The question is where it sits in the sequence. If the Great Filter is behind us, is the rare step is something that already happened in Earth's past, like the emergence of the first self-replicating molecule, or the development of eukaryotic cells, or the evolution of multicellular life, then we may be genuinely extraordinary, a fluke, the lucky survivors of a filter that almost nothing gets through, and the universe is silent because almost everything else never made it this far. If that is true, then we should feel fortunate. Rare, perhaps, but safe. But if the Great Filter is ahead of us, if the rare step is something that almost no civilization survives after reaching our level of technology, then the silence has a different meaning. It means that civilizations like ours routinely develop and then fail to continue. That something destroys them. War, environmental collapse, engineered pandemic, artificial intelligence, some form of self-destruction we have not yet encountered. That the reason the sky is silent is that the things that would have filled it are gone. That possibility is one of the most disturbing ideas in all of modern thought. There are solutions to the paradox that are less terrifying. They are not more comforting exactly, but they involve civilizations surviving rather than dying. The zoo hypothesis suggests that advanced civilizations are present and aware of us, but have chosen not to make contact. Perhaps there is a policy among spacefaring civilizations to observe younger species without interfering, the way conservationists observe an endangered animal without disturbing it. We are in a protected reserve. The silence is policy, not absence. A variation of this is the dark forest hypothesis, developed by Chinese science fiction author Liu Cixin, and now taken seriously by some researchers as a genuine possibility. The dark forest proposes that the universe is filled with civilizations that are all hiding. Broadcasting your existence is dangerous, because any sufficiently advanced civilization that detects you may treat you as a potential threat and eliminate you before you can become one. In a universe where the resources of stars and planets are finite and the laws of physics are constant, the optimal survival strategy for any civilization may be silence and concealment. The forest is dark because every creature in it is hiding. Under the dark forest model, the SETI programs broadcasting humanity's location, including the 2012 Arecibo reply to the WOW signal, may have been catastrophically reckless. We have been announcing our presence to a universe in which the correct response to such an announcement might be elimination. Most scientists do not consider the dark forest a likely scenario, but the logic of it is internally consistent, and unlike many proposed solutions to the Fermi paradox, it does not require us to be special or rare. It requires the universe to be adversarial, which, given what we know about natural selection, is not entirely implausible. Then there is the possibility that does not require civilizations to be rare or hostile or hiding. The possibility that the search itself is the problem. Humanity has been broadcasting detectable radio signals for approximately 100 years. Those signals have traveled 100 light-years from Earth, a bubble of radio noise surrounding us, detectable by sufficiently sensitive equipment, expanding outward at the speed of light. The Milky Way is 100,000 light-years across. Our broadcast bubble covers 1/10% of its diameter. The civilizations that might be listening are, statistically, much farther away than 100 light-years. A civilization 4,000 light-years from Earth would not know we exist. Our oldest radio signals have not reached them yet. They are in our future. And we have only been listening carefully for about 60 years. The SETI search began in earnest in 1960 with Frank Drake's Project Ozma. 60 years of systematic listening across a fraction of the frequency bands available, targeting a small fraction of the sky, with instruments that improve every decade but remain far from omnidirectional or comprehensive. We have not searched for very long. We have not searched very widely. We have not searched across all the frequencies a transmitting civilization might use. The argument that absence of evidence is evidence of absence may be premature, given the scale of what we have not yet examined. But this explanation has a limit. We can excuse 60 years of fruitless searching as insufficient. We cannot easily excuse the fact that no Type 2 or Type 3 civilization has made itself structurally unmissable, that no Dyson sphere has been confirmed, that no megastructure appears in any of the billions of galaxies examined. Those would be visible, regardless of whether we are listening on the right frequency. There is one more explanation that deserves attention, because it is the most scientifically grounded and the most unsettling. The universe is 13.8 billion years old. Earth is 4.5 billion years old. The first generation of stars, the ones that formed from the primordial hydrogen of the Big Bang, did not contain the heavy elements needed for rocky planets and organic chemistry. Those elements had to be created inside stars and scattered by stellar explosions over billions of years before the universe had the chemical ingredients for life as we know it. Some researchers argue that the universe may only recently, in cosmic terms, reach the level of chemical complexity needed for life like ours to exist. That the stars necessary, the planets necessary, the chemical abundance necessary have only been widespread enough for a few billion years. And that an intelligence like ours, requiring all of those ingredients plus billions of years of evolution, may be emerging at roughly the same time as the first such intelligences, anywhere. Not the only intelligence, not necessarily the most advanced, but near the leading edge of what is cosmologically possible at this stage of the universe's history. If that is true, the silence is not a sign of death or hiding or rarity in some extreme sense. It is a sign of timing. We are early. The universe is young enough, in the relevant sense, that the explosion of intelligence has not yet happened. We may be living in the moment just before the galaxy becomes loud. Or we may be wrong about that too. No proposed solution to the Fermi paradox has been confirmed. Most of them have not even been seriously tested, because testing them requires either detecting an extraterrestrial civilization or explaining the absence of one, and we have been unable to do either. What the Fermi paradox has done is force a confrontation with a question that science had previously allowed itself to defer. Whether we are alone in the universe is not just a philosophical question. It is an empirical one, with an answer that exists somewhere. Either other intelligent life exists, or it does not. The universe knows the answer. We do not. And the fact that the most mathematically expected outcome, a universe full of communicating civilizations, does not match the observable reality, is a data point. A significant one. It tells us that at least one of our assumptions about the prevalence of intelligence in the universe is wrong. Either life is rare, or intelligence is rare, or technology is rare, or longevity is rare, or something filters civilizations before they become detectable. Or they are present and hidden. Or we are simply not looking correctly. One of those must be true. The silence demands an explanation. And every explanation available carries consequences for what we should think about our own civilization, how special it is, how fragile it may be, and whether the story of any technological species tends to have a particular kind of ending. Here is the question underneath all the other questions. If the great filter is ahead of us, if advanced civilizations consistently fail to survive, what is the filter? And are we approaching it? We are 1 century into the development of nuclear weapons. We are in the early stages of creating artificial general intelligence with capabilities we cannot fully predict. We are altering the climate of our planet at a rate with no geological precedent. We have developed biotechnology capable of engineering pathogens. We are accumulating capabilities that could, if mismanaged, end our civilization. None of this is inevitable. None of it is a prediction. The fact that we face these risks does not mean we will fail to navigate them. But if the universe is full of civilizations that reached our level of technology, and most of them did not make it through, then those risks are not just our risks. They are the statistical story of intelligence in the cosmos. The reason the sky is silent may be that this moment, right now, the century when a civilization goes from radio to nuclear to AI to biotechnology in a single human lifetime, is the moment that most civilizations do not survive. The physicist Stephen Webb wrote a book on the Fermi paradox in which he listed 50 proposed solutions. Every one of them, he noted, required accepting something uncomfortable about either the universe or ourselves. That is probably the most honest summary available. The search continues, and it is more sophisticated now than it has ever been. Breakthrough Listen, the $100 million SETI program funded by Yuri Milner, is surveying more stars, more frequencies, and more galaxies simultaneously than any previous effort. Its data analysis pipeline can process in hours what would have taken previous programs years. The James Webb Space Telescope is beginning to analyze the atmospheric chemistry of exoplanets, looking for biosignatures, chemical signs of life in the spectra of alien atmospheres. The search is no longer just about radio signals. It extends to atmospheric chemistry, thermal emissions, technosignatures of every kind that technology might produce. The search has never had better tools. The search has never produced a confirmed detection. That tension between the sophistication of the effort and the emptiness of the result is itself a form of data. If a civilization broadcasting the right signals existed within a few hundred light years of Earth, and if those signals fell within the frequency ranges Breakthrough Listen monitors, it would very likely have been detected by now. The fact that it has not been does not prove no such civilization exists. Signals could be weak, directional, intermittent, on frequencies we have not checked. But it narrows the space of what is plausibly out there near us. And every year that passes without a detection is one more year of data saying that at our scale of effort, looking in our direction, the universe is still not answering. Every night, the sky is full of stars, hundreds of billions of them in this galaxy alone. Around many of them, planets orbit in the right zone, at the right temperature, with the right chemistry for something to have emerged and looked up and wondered whether it was alone. The math says many of them should have. The sky says none of them have told us about it. That contradiction between what the numbers predict and what observation finds is one of the most profound open questions in the history of science. Not because it is abstract, but because the answer tells us something fundamental about what we are. If we are alone, the universe is almost unimaginably vast and almost unimaginably empty, and everything that has ever thought or created or wondered is here on this small planet, in this ordinary galaxy, in this unremarkable corner of the cosmos. If we are not alone, and they are simply not talking, the question of why changes how we should think about our future, and about whether the silence is protective, indifferent, or a warning. And if the great filter is ahead of us, if what the silence is telling us is that civilizations do not last, then the silence is not just strange. It is a message, addressed to any species that develops the technology to hear it, saying, you are not the first to reach this point, and most of those that came before you did not continue. One of these possibilities is true. We are somewhere inside one of them right now, and we do not know which. What do you think the silence means? Leave your answer in the comments, and subscribe, because wherever we land on this question, we will be covering it every step of the way.